Hello friends, in this video I will explain how you can analyze a spring slip system that is under circular motion. So this problem says a bent rod ABC is pivoted freely at point C about which it rotates at uniform angular speed omega in a horizontal plane as shown in this figure. On arm AB, a spring of natural length L and force constant K is attached at point B, and on its other end a movable sleeve S is attached which can smoothly slide on the rod. So we have to find the elongation of a spring when the sleeve is in equilibrium on the rod. So we have been given a L kind of rod. So this is the rod, L type rod, and on this rod there is a spring. So this is the spring and there is a sleeve, and this sleeve can freely move on this rod, and this L type rod is rotating with angular velocity omega. So this is given and this is fixed at point C. So motion is happening perpendicular to the plane of the figure. And this all motion is happening in a horizontal plane. So if you see, this sleeve is basically rotating in a circle. So this sleeve is moving in a circle. So this is the path of this sleeve. Force constant of a spring is given, so that is K. So what are the things that is given? So we have been given omega, that is velocity by which this is rotating, that L kind of shape of rod. K is given, and then natural length of a spring is also given, that is L. But now when this is rotating, a spring will also elongate, and that's why this length will be more than the natural length. So let's say this spring elongates by x, then the total length now will be L plus x. L was the original length, and this x is basically a stretching or elongation in the spring. So how will you solve this problem? You have to find this x. What is x? That is, what is elongation? Find the elongation in the spring. You understand why there is elongation? Because this sleeve is trying to rotate along this circle, and then there is a tendency for this sleeve to move out, and that's why there will be a elongation in the spring. So how will you solve? So you write two equations, one equation for circular motion, that is along the tangential direction, and another along radial direction. You know this is a uniform circular motion. So why this is given? This is given in the problem, that is uniform circular motion. So if uniform circular motion, this means tangential acceleration is 0. This means force in the tangential direction is 0. So this is one equation you will get from here. And the second equation you will get, that is force in the radial direction is equals to mv square by r, and v is equals to r omega. So you can also write m omega square r. So let us write these two equations and you will be able to solve this problem. So pause this video for a few minutes and solve yourself. Okay, let us try to solve this problem now. So we will solve this. So what are the things that is given? So let me first make once again the free body diagram. So this is the rod that we have, and this rod is rotating about this point, and this, say, let us say after some time this sleeve is here. So sleeve is here. So this is the sleeve position. Basically you can consider rod a little bit longer. So this is the rod. Now let us say this length is L plus x. So what are the forces that is acting? Now see, one force, because there is elongation in the spring, x is the elongation, so force will be k times x, and that will act in this direction. Another force that the slip will apply, or basically this L kind of rod will apply on this slip, that is normal reaction. And now this is moving in a circle. So this slip is moving in a circle. So this is the part of circle. So we can write two equations. One equation in this direction, that is the radial direction. Let us call this angle as theta. So this length is L plus x, then this length will be L plus x divided by cos theta. You can verify yourself. Now let us write equation in the radial direction, that is force in the radial direction is equals to mass into acceleration in the radial direction. So what are the forces? You will have this kx, component of kx in the radial direction will be kx cos theta. And normal reaction will have a component, so this angle is theta. So this angle will be 90 minus theta. So normal reaction will also have a component in this direction, and that will be n sin theta. So force towards the radial direction we have, that is kx cos theta plus n sin theta is equals to m omega square r. R is how much? So this length L plus x divided by cos theta is r. So this, in this case, you can see this is r. So this length is r because radius along which this is moving. So this length is r. So this is equation 1. Now the second equation you will write from force is in the tangential direction is equals to mass into acceleration in tangential direction. But this is uniform motion, so tangential direction force has to be 0. So what are the forces that is acting in the tangential direction? So normal reaction component in this direction will be, so this side you have n sin theta, so this side you will have n cos theta. And this direction you will have this kx component, so this will be kx sin theta. So you can write basically n cos theta is equals to kx sin theta. So from here you can write n is equals to kx sin theta divided by cos theta. Now you have two equations, you can solve these two. So plug the value of n in equation 1. So from equation 1 we can rewrite, that is kx cos theta, and n is nothing but kx sin theta divided by cos theta times sin theta is equals to m omega square L plus x divided by cos theta. Now this will become kx cos square theta plus kx sin square theta, and this divided by cos theta is equals to m omega square L plus x divided by cos theta. So cos theta cancels out, and here you will have cos square theta plus sin square theta, that will be 1. So you can write kx is equals to m omega square L plus x. From here you can solve for x. What will happen? You can take x common this side, so you will have k minus m omega square. K minus m omega square, and here you will have m omega square L. So from here you can say x is equals to m omega square L divided by k minus m omega square. So this is the elongation that you will have in this spring. Now question for you. This problem can also be solved in the rotating frame. So rotating frame. In that case, how many equations you will need to write? And do you have normal reaction also there? In this case, you have two unknowns. X is unknown and normal reaction is unknown, and that's why we have written two equations. Now, if you use rotating frame and you write equation of motion, how many unknown you will have? Will n be there? Will x be there? Let us discuss all this in the comment section. And I will see you in the next video. I hope you enjoyed this video, and if you enjoy, please share with your friends, and this will also help to grow my channel. Thank you.